Right, this is video 2 for your Unit 14 review, picking up with question 9. Video 1 had 1 through 8. So express 2 times e to the x minus 2 power equals h of x in logarithm form. So the first thing we need to do is divide by this 2 here. So we get e to the x minus 2 power is equal to h of x over 2, or you could say 1/2 h of x. It doesn't matter. I'm going to keep it this way. And then we discussed, when we talked about this in class, that when you want to write it as go from exponential form to logarithm form, the base stays the base. So I'm going to write the logarithm with base e. The base of the exponent was e. The base of the logarithm must also be e. And everything else will cross. So the argument of this logarithm is going to be this part. It's coming over here, the h of x over 2. And that will equal, this part is going to the right side. So the part in the exponent location goes there, and we're done. We could also write it ln of h of x over 2 equals x minus 2, because log base e and ln are the same, so either way is fine. Problem 10 says simplify log base 4 of the square root of 32. So we're going to set up the loop rule to do this. So we'll set it equal to x and convert it into an exponential using the loop rule. So 4 to the x power is equal to the square root of 32. Do some simplifying here. 4 to the x equals 32 to the 1/2. So I'm going to make that root, turn that into a fractional exponent there. And then I need to satisfy or get like bases here, and I can do that because 32 is 2 to the 5th. And 4 is 2 squared, so I'll do that next. So 2 squared raised to the x power is equal to 2 to the 5th raised to the 1/2 power. So I just made the 32 2 to the 5th and the 4 2 squared. I still have the exponent of x on the left and 1/2 on the right. Alright, so now outside to inside rules here, that would be 2 to the 2x power is equal to 2 to the 5/2 power, outside to inside, 5 times 1/2, 5/2. Now I have like bases, so I'm allowed to set their exponents equal to one another and solve. So 2x equals 5/2 here. So now divide by 2, divide by 2. Dividing by 2 is the same thing as multiplying by 1/2. So x is equal to 5/2, we'll do it off to the side, times 1/2. Is equal to 5/4. So x is equal to 5/4. Answer, x equals 5/4. For clarification, x equals 5/4. That means that log base 4 of the square root of 32 simplifies to 5/4. Okay, we set this thing equal to x in the beginning, so I want to make sure that you understand that what we are saying here is that this simplifies to this. Okay, number 11, simplify e raised to the negative 4 times ln of 3 power. So the first thing I'm going to do is start condensing here. So I'm going to take this negative 4 multiplier and move it up as an exponent here using our logarithm theorem. So that would be e to the ln of 3 to the negative 4 power. Okay, and then we have a property of logarithms. It's not a theorem, but it is a property that if you have an exponent and a logarithm with the same base in the problem together, that you can simply cross those out and you're only left with whatever is in this location here. So that's what we're going to do here, because we have a base of e for our exponent and we have a base of e for our logarithm here, both of those. So we're only left with everything that is not crossed out. So it equals 3 to the negative 4 power, which is equal to 1 over 3 to the 4th power. And if you work that out, that is 81. 3 to the 4th is 81. So 1 over 81 is what that simplifies to. So e to the negative 4 times ln of 3 simplifies to 1 over 81. All right, problem 12. Gone ahead and copied over our log theorems for us to use here to reference. I've also rewritten this so that we don't have that slash in place of this horizontal fraction bar here, so we can see what is going on here. When we expand, we'll be going from this side of the theorems to this side. So we have a multiplication here between the 4 and this 3x minus 7 quantity, and we have a division here of x squared. So multiplication becomes addition, division becomes subtraction using these two theorems. So log base 5 of 4 plus log base 5 of the quantity 3x minus 7 minus log base 5 of x squared. So that's what we've done so far. We split this multiplication into this addition here, and this division became this subtraction here. So they're all log base 5. So we now have 3 logarithms. There is one more thing that we can do. We can expand this a little farther by moving that 2 exponent up in front there using this third theorem. So we have finally log base 5 of 4, that's the argument there, put that in parentheses, plus log base 5 of the quantity 3x minus 7, the argument there is this 3x minus 7 quantity, and subtract 2 log base 5 of x, and that is fully expanded. Okay, problem 13 says condense. So when we condense, we're going to be going from this side of the theorems to this side of the theorems. We're going from more stuff to less stuff. Okay, so we'll take this one step at a time. This part right here, we're going to pull that 8 multiplier up as an exponent and condense that. So ln of x to the 8th. And then I'll just keep everything else the same, and we'll go through multiple steps here. Okay, now the additions, so that would be that one's positive and that one's positive. Those are the additions. Those are going to become multiplications. Those arguments will be multiplied together in our final logarithm, the x to the 8th and the x here. And then the subtraction right here will become a division. So its argument will be divided in our final condensed logarithm. So we have ln of x to the 8th times x all over the quantity x plus 5. One final simplification. X to the 8th times x is x to the 9th all over x plus 5. And that is the final condensed argument of our logarithm. So that's it for 13. All right, problem 14. Evaluate log base 10 of 1 over 100. There's no base listed, so it's implied to be 10. So there are two ways to do this. I'm going to do it both ways. So 1 over 100 is the same thing as 1 over 10 squared. Okay, and then that can be simplified down to 10 to the negative 2. 1 over 10 squared, 10 to the negative 2. You take this positive exponent that's on the bottom, you move it with its base up and to the top, and its exponent becomes negative. So 1 over 10 squared, same thing as 10 to the negative 2. So then we can set this equal to x and simplify. So we're going to convert it into an exponential here. So 10 to the x is equal to 10 to the negative 2, which means that x has to be negative 2. So we evaluated that, and it's equal to negative 2. So that's one way to do it. The other way to do it is we can use our theorem. So we're doing this, log of 1 minus log of 100, like that, because we're taking this division and splitting it into 2 logarithms, and the numerator goes here, the denominator here, of the original fraction there. Log base 10 of 1 is equal to 0, minus log base 10 of 100 is equal to 2. So 0 minus 2 is negative 2. Why is log base 1 equal to 0? Well, let's do that off to the side. Log base 10 of 1 equals what? Well, 10 to what power equals 1? That's what we're saying. 10 to what power equals 1? Well, that would be the 0 power. In a similar fashion, why is log of 100 equal to negative 2? Well, log base 10 of 100 equals what? So 10 to the x power, 10 to what power, we could say, is equal to 100? Well, 10 to the second power equals 100. So that's why that one was 2, and then we were subtracting it. That's why that sign's there. So either way, you end with negative 2. So this is method 1, this is method 2. You get to your answer of negative 2 either way. All right, problem 15, last one for this video. Reduce to a single log and simplify. Okay, so we're going to pull this pi up as an exponent right there. That's the first thing I'm going to do, and then we'll go from there. So that would be ln of 2 raised to the pi power plus ln of 2 raised to the 2 pi power plus ln of 6. So we have the like bases here, so we can apply our log theorems. We're adding these three logarithms, logarithm 1, 2, and 3. So we can combine them into a single logarithm by multiplying their arguments. So we would have 2 to the pi power times 2 to the 2 pi power times 6. So we're taking that argument, and that argument, multiplying them all together because of this theorem right here that allows us to do that. And 2 to the pi power times 2 to the 2 pi power. Notice the bases are 2 in this case, so we can add their exponents. So we have pi plus 2 pi. So 1 pi plus 2 pi's is 3 pi's. So ln of 2 to the 3 pi times 6. And that is it. We cannot simplify this anymore. This is our answer. It is a single logarithm. Do not make the mistake of trying to multiply that 2, this base of 2, times this 6, and make it 12. If you wrote this, that is wrong. It is not 12 to the 3 pi. You cannot do that because it's not just 2 that you're multiplying by. It's 2 to the 3 pi power. So leave it like this. Don't multiply that 2 times that 6. All right, that's it for this video. We'll pick up with 16 in video 3.